Welcome everyone to this McCulloch's neuron model lecture. This model was introduced in 1943 by Warren McCulloch and Walter Pitts. It's a simple mathematical model of neuron based on binary inputs and binary outputs. All right. So this basic architecture was modeled after the working of a biological neuron. All right. Its components are inputs x1, x2, x3, and up to xn, weights w1, w2, w3 up to wn. Each input is then multiplied by the weight to signify its importance. Then there is the summation function, which uh, the inputs of are summed up and compared with the threshold. All right, and the activation function, which is also the called as the step function. Basically, what it does is if the sum exceeds the threshold, it fires, that is outputs 1, or else it outputs 0. Okay, so what is given over here is basically this model which we saw in the previous lecture, the biological neuron, is replicated over here. So x1, x2, x3, consider this as inputs. Each input is associated with a weight to signify its importance. All right. Then a sum of products is calculated, SOP. All right. And after that, the sum of products is calculated. It is passed through a threshold. All right. And that threshold is set by us. Okay. So based on the threshold, the output will either be 0 or 1. Okay, so if it is greater than the threshold, then output will be 1. If it is lesser than the threshold, output will be 0. This is a simplest model which was made by McCulloch Pitts, McCulloch and Pitts in 1943. Okay, so what can this McCulloch-Pitts model be used for? It can be only used to on data which is linearly separable. Okay, it only works for linearly separable data. So what do I mean by linearly separable data? Okay, so consider the case of AND gate. Okay, let me just tell you how AND gate works. This is the this x1, this x2, and this is the output. Output will represent by y. Okay, so when it is 0 0, the for AND gate it will be 0. For 1 0 1, it will be 0. For 1 0, it will be 0, and for 1 1, it will be 1. Okay, so this is the output. All right, so now when we want to write this in when we want to show it in, say, x and y x and y coordinates, what happens is 0 0 is always given over here, right? 0 0 is over here. All right, 0 1 is here, 1 0 is here, and 1 1 is here. Okay, now this, what do I mean by linearly separable data? That is, we can draw a line, okay, a line in such a way that it will divide the data in such a way that all the zeros are on one side and all the ones are on one side. Okay, so you will see this 0 comma 0, this 0 comma 1, and this 1 comma 0. All these have output as zeros, whereas 1 comma 1, here 1 comma 1 has output as 1. Okay, and that is on the other side of line. So such problems are called as linearly separable problems. Okay, so that is called as linearly separable, and such problems which are linearly separable can be solved by McCulloch-Pitts model. Okay, but it cannot solve problems which are not linearly separable. Now, which might that be? So that is XOR gate. Okay, if you take the representation of XOR gates in the way that we just saw for AND gate, then you will come to know that XOR is not linearly separable. That is, we cannot draw a line in such a way that all the inputs, zero outputs, sorry, are on one side and all the ones are on other side. Okay, so that is the characteristic of the McCulloch model, that it can only work for linearly separable data. Okay, other characteristics are the inputs and outputs are binary, as we said. It uses a hard threshold. So the threshold given over here, okay, is set by the user. So it could be 1, it could be 2, it could be 3, whatever is the threshold. It is a hard set threshold. All right, and there is no learning happening. So what do I mean by learning? Once you get the output, okay, you do not change the biases, weights. Sorry, no bias. There is no bias. You cannot change the weights to get accurate prediction. Okay, you only have a single run throughout the neural network. Okay, in this case it's only one neuron. So basically throughout the neuron it's only one run, and based on the what weights you have considered, you will have your output, weights and thresholds, sorry. Okay, so you will have your output, and it is a very deterministic behavior. That is, there is nothing that we do not know, because we will be the ones who will be setting the weights, we will be the one who is deciding the threshold. So everything is actually known to us. Okay, the flaws, as I said, it has no learning. It cannot learn non-linear data. All right, I already mentioned that. Non-binary is not applicable. So if your data has multiple classes, okay, more than one classes, it is not applicable, and there is no bias term. Okay, so sometimes we need bias. What is bias? Basically, if we say that I hate this person, okay, or I love this person, okay, the case of hate, there is a negative sentiment attached to the person. Okay, there is a negative bias again, that is, the bias is against that person. And if I say I love that person, it basically denotes a positive sentiment or a positive bias. Okay, so I will have I guess that clears it up. Okay, so the bias can either be negative or positive, but we don't have any bias over here introduced. Okay, in later versions of neural networks we will have bias as well. Okay, why bias is necessary? Because sometimes it is very clear from the data that uh, certain values used to be are to be included. Okay, so that is where the bias comes in. That is, say we want to add 5 to our, for example, let's assume that bias is equal to plus 5. Okay, so what will happen is we will add plus 5 to our model, is this to this SOP. All right, and that will change our behavior, the behavior of the model by a little bit. Okay, so that basically concludes the discussion on McCulloch model. Okay, uh, now the in the next lecture what we'll see is a single layer perceptron. Okay, so the flow of the evolution of this neural networks is in this way. That is, we have this McCulloch model, neuron model first, followed by perceptron, single layer perceptron, followed by multiple layer perceptron, multi-layer perceptron. Okay, and then followed by deep learning neural networks. Okay, so we have covered McCulloch model. In the next lecture we will see our perceptron. Thank you.